Hello and welcome back to the Coder's Legacy channel. In today's video, we're going to explore how to create widgets in Matplotlib. Matplotlib has a bunch of special widgets, special GUI elements that can be added to the canvas to control the behavior. Basically, they allow for user interaction, which can change the behavior of your graphs, like a button which can maybe change the color of your graph, or a check button to maybe hide or show a certain graph. So that's the kind of things we can do with Matplotlib widgets. And in this video, we're going to basically cover all of them. A brief look. We'll take one example for each widget, all right, and cover each one of them. And also teach you along the way a few other important concepts that you'll need when creating widgets, okay? So let's begin. The first thing you need to do is import a widget that you want to use from the matplotlib.widgets module, okay? We're importing button here, and I've already written the code out beforehand because we're going to go through 6 examples, one for each widget. There are more than 6 actually, but 6 main ones that we're going to look at in this video, okay? So I've already written the code out. We're just going to talk about it, and I'll explain how it works. Okay, so first I'll execute this, okay, and we'll look at the output, and then I'll explain it. Here is our output. Here we have 2 buttons, and we have a sine wave. Now if I click next, its frequency is basically increasing, okay, and again and again, and then this loops back, and the previous button is the reverse. So first of all, the first thing that we need to discuss is how did we place those buttons down there. Now the thing is that this line is very crucial. What it does is moves our matplotlib graph a little above. You need to understand that the matplotlib window and the matplotlib graph, they're two different things. There's the axis, okay, where the graph is drawn, and then there's the matplotlib window. These are two different things. What we're doing over here is moving basically the axes 20% up. Okay, this is basically on a scale of 0 to 1. We're moving it up by 0.2. We're basically defining the start point. By default, this is 0. Okay, and if I actually run it like this, you'll see that it's basically causing problems. Okay, I think there's some padding normally done, but if I just remove this, you'll see this. Okay, that's why we do bottom is equal to 0.2 to move it up a bit. Or if we wanted to put our buttons to the left, then we would, adjust it from the left. Okay, now the next thing is, well, this is just the code for the plotting. That's not important. Then over here we have 2 functions, previous and next, that are linked to our buttons. Our 2 buttons over here. Now this is where we actually create the axes for our buttons. The graph has the axes, and the widgets, every widget has an axis where you draw that widget to. So this is the first axis for the previous button, and this is the axis for the next button. What is this parameter over here? Well, this is basically a list that contains 4 values. The first 2 values represent the x and the y positions respectively, the starting positions, and the next 2 values represent the width and the height respectively. And again, all of this is on a scale of 0 to 1. Okay, this basically means put this on the 60th, 60% position, okay, on the x-axis. So if there are 100 units on the x-axis, this will make a start from the 60th. And this is the width. So basically it means it's going to be 12 pixels wide, okay, assuming the scale is from 0 to 1. And yeah, that's basically how it is. Now this is just creates the axes. You need to actually create the button over here by using the button class. The first parameter is the axes that you created, and the second parameter is the label. And then you can connect that button to a function. There's nothing really much more to discuss. The functions are pretty simple. They're just connected to a global index that keeps track of which frequency is currently on. There's a frequency array over there which contains 5 frequencies. We're just updating the current Y data updating the y data, and then drawing the new changes to our graph. Let's take a look at the next example. Here we have the code for a slider widget. Let's run our code first. And here it is. Okay, so basically we have a slider, and we can adjust this slider to change the frequency of this graph. Interesting, right? So how does this code work? Well, there's nothing really special. We already discussed what this does, and there's very little code actually. We've created the axes here the same way, just given it a lot of width, and we created the slider, passed in the axis object, gave it a label, a minimum value, a maximum value, and an initial value, and then connected it to a function which updates the y data. And so this is the same function, similar to plt.draw, and updates the graph with the new data. Now for our fourth example, the third. Okay, so here's the text box, and let me run this code. This is basically a way of taking input from the user. This is basically an input field, and the user can enter an expression in here, and it's gonna evaluate it and draw a graph. So for example, I can change this to t to the power 3, and it draws this. Or for example, x plus y. Oh wait, I think I'm using t. Okay, so let's go with things in terms of t. T plus 3, okay, and something like t plus multiplied by 2 plus 6, and obviously that's still going to be a curve, a straight line. And then let's do this. We can adjust this a bit, and just changing that on the y-axis. Yeah, so pretty much that's what we can do over here. Let's just talk about the code a bit. Here is the evaluation. What we're doing is using the Python eval function, which evaluates that expression, but that's not important. Let's take a look at this. This is the text box widget. Basically, again, we created the axes, passed the axes into the text box widget, gave it some text, and then aligned that text, and then just linked it. And also we set an initial value into our input box. Okay, if we just left this blank, then there wouldn't be anything in there. Like if I do this, oh wait, I should remove that. And this triggers the submit function that you linked it to, by the way. Okay, so currently it's empty, pretty much. So yeah, that's this. There's nothing really nothing of importance here. This is just something interesting, that when you update the graph in a way that it might go out of the window, then what you want to do is call these two functions, which basically adjust the axes accordingly and resize the view to ensure that you can see the whole graph in your viewport. Okay, and then again we just update those changes. Here's our fourth example using RadioButtons, and again let's run the code first. We can change this options over here. Okay, change which one we have selected, and the color of the graph updates accordingly. Now, one thing you can notice immediately is that the position of this is different from where we were keeping it previously in the previous videos. So it's on the left, right? So what we've done is basically moved our graph to the left. Okay, we've given it an offset of 0.3, 30%, basically. And again, we create the axes for the radio buttons, and then this is the radio button widget. Pass in the axes, pass in the required labels, as many as you want to, and then active decides which one is going to be active. You don't have to, I think, but it defines which one of these is going to be selected when the window opens. And this is indexing, basically, starts from 0. Active color defines the color that, well, let me just show you. If I change this to red, then this you see here, it becomes red. Okay, previously it was yellow. And then again we have the set color. What is this? Oh yeah, we're updating the color of the graph with radio value selected. Okay. Oh, okay. I know what this is. I was a bit confused over there. This is the function that connects it to this function fires. Set color over here is a way of manually setting the color. What we've done here is like if I didn't do this, for example, then and I executed this code, this is currently selected on green because I did active is equal to 2, but the graph is still blue. Blue is the default color. So what you need to do is manually call this function. Okay. Now for our fifth example, here we have the check button. This is again a pretty useful widget that we can use to, well, present to the user a bunch of options, and he can select as many as he wants to. Okay, unlike radio buttons where you can only select one, check buttons you can have multiple selected. So you can see here that we have these three options, and let me just deselect that. These are different frequencies for the sine wave. So we can have 1 hertz on, we can even turn it off. We can have 2 hertz on or 4 hertz, or we can even have all of them on at the same time. So this is what a check button can do. And we created 3 different plots over here. A plot function returns an object, okay, a line object. And that's something not a lot of people do. You just do this directly, but you know, it returns a line object. And what we do is store all of these line objects inside this lines array. And then we use that to basically set its visibility when we click on the check button. The code looks a bit fancy over here. It's not actually that fancy. It's just doing something really basic. It's basically toggling the visibility. Okay. And yeah, pretty much. And what is this? Yes, this is our check buttons class, and it takes the axes that we created. It takes the labels. Okay, where are the labels? Oh, over here. This is basically a way of getting the labels automatically from these lines. Okay, and we do this, and then visibility. Yeah, visibility is it defines which ones will be visible at the start. Okay, and we use this later. This is an array which basically stores the visibility states, whether it's visible or not. And we're doing this for each of these line objects. A line object has a getLabel function. It has a getVisible function that returns its label or visibility respectively. Okay, so that's what the check button needs to be created. And yeah, that's about it. Let's move on to our last example. This one is pretty simple and doesn't really have much value, but it can be useful in some cases, I guess. So I thought I'd mention it. It's basically a special kind of cursor widget. I think this could be useful in interactive applications where you want to select something. So it's kind of useful as a cross chair, as a helpful cross chair. And yeah, you can. I've actually linked this to. I've actually made this a graph interactive just to kind of showcase its use. Using the pick event, you can make it so that whenever you click on any artist refers to an object like a dot or a line that has been drawn to the graph. Anytime you click on an artist, it's gonna call this function. It's gonna print out its coordinates, basically. Let me run that again and let me show you how this works. I'm gonna click on this dot and you'll see its location being printed out. If I just click randomly like I am right now, nothing is gonna work because I'm not clicking on an artist. But let me click on an artist, it's gonna print that out. Okay, cool, right? And with this, we're pretty much done with the video. I think we've covered quite a few, covered all the important widgets really. The other ones are really niche. And we also discussed a bunch of other interesting concepts along the way. Hope you guys enjoyed the video and found it useful. All right, see you guys in the next one.